Okay, we have taken a look at inequalities. We already covered addition and subtraction. We did multiplication and division. We only did one-step inequalities. So now, of course, we would like to take a look at multi-step inequalities where you now do addition, subtraction, as well as multiplication and division. Recall that there are two major rules for inequalities. When you multiply or divide by a negative value, you flip the sign. When you flip the variable to the other side, you must flip the sign. Two-step or multi-step inequalities, you have to clean up both sides before you can begin. We did all this cleanup process in Unit 1. I need you to go back and look at that. We isolate the variable just like an equality, and you start with addition and subtraction. So different than order of operations, when you're cleaning up and you're solving multi-step equalities or inequalities, you start with addition and subtraction. Let's take a look at our first one. 7y minus 4 is greater than 24. So I know that I need to isolate y. I need y to live alone, so I need to get rid of the minus 4 first. So I add 4 to both sides, and I go ahead and I eliminate the 4, and I am left with 7y is greater than 28. Now I still need y to live alone. So I divide both sides by 7. I am dividing by a positive value, so I do not flip the sign. Y is greater than 4. Open circle at 4, shade to the right. Let's try another one. Negative 2x plus 4 is less than or equal to 10. Remember that you only flip for multiplication and division, not subtraction. I need to isolate x. I start by going from the farthest term away from x, which is the plus 4, which is addition. The inverse of addition, subtraction. I subtract 4 from both sides. I do not flip the sign. You do not flip the sign for addition and subtraction. Negative 2x is less than or equal to 6. In this case, now, in order for x to live alone, I must divide by negative 2, and when you divide both sides by a negative 2, you must flip the sign. And now I have x is greater than or equal to negative 3. Solid circle at negative 3, shade to the right. I have a plus 5. I subtract 5 from both sides. I am left with 3k is greater than 6. I need to isolate k, so I divide both sides by 3. And when I divide both sides by 3, that's a positive value. I do not flip the sign. The 3's cancel each other out, and k is greater than 2. If you were to graph it, open circle at 2, shade to the right. Negative 4x plus 6 is greater than or equal to 14. You will start to notice that when the coefficient of the variable is negative, you're probably going to flip the sign. But let's start at the beginning. Get rid of plus 6. So I subtract 6 from both sides. I am left with negative 4x is greater than or equal to 8. Divide by negative 4 and flip the sign. You do it right away. Do not wait to do it. X is less than or equal to negative 2. I would put a solid circle at negative 2 and shade to the left. In this case, I'm going to get rid of the minus 6 first, and I'm going to add 6 to both sides. I am left with x divided by 2 is less than or equal to 10. How do I get rid of the denominator? I multiply. Multiply both sides by 2, which is a positive value, so I do not need to flip the sign. They cancel each other out, and x is less than or equal to 20. 34 is greater than or equal to negative 7x minus 15. I see that the x is on the right-hand side. I'm not going to worry about it yet. I need to clean up both sides and solve first. So I need x to be isolated. I need to get rid of the minus 15. I use the inverse operation, which is plus 15 to both sides. 49 is greater than or equal to negative 7x. Divide by negative 7 and flip the sign. 49 divided by negative 7, rules of operations, rules of integers, negative 7 is less than or equal to x. Now, I've already flipped the sign, but x is still on the wrong side. So now when I move x to the left, I flip the sign again. X is greater than or equal to negative 7. Do you see that I flipped the sign twice? That's why I always want to encourage you to do one step at a time. Don't try to do all of it in your head. This is why you show your work. If you show your work, you realize right here that you have flipped the sign, but you're not done. X is on the wrong side. So you flip the sign again. Multi-step inequalities. We know from equalities that you have to clean up before you can begin. Our cleanup process, 3 of the main parts of it are, if you have more than one step, you combine like terms, you use distributive property. So I have to clean up. I have to combine my like terms. I'm going to use my distributive property. 6n plus 3n is 9n. I have a 9n plus 10. Now I'm clean. I have a plus 10, so I subtract 10 from both sides. And I have 9n is greater than negative 27. So, divide both sides by 9. Actually, divide every term, but in this case, there's only one term on each side. And I get n is greater than negative 3. Just because that is a negative 27 does not mean you flip the sign. You divided by a positive 9. So you do not need to flip the sign. I need to clean up. I need to combine like terms. So if I'm going to combine like terms, I have a negative 3w and a negative 2w makes a negative 5w plus 3. Subtract 3 from both sides. Negative 5w is less than 5. A positive 8 and a negative 3 is a positive 5. Now I'm dividing by a negative 5. Divide both sides by negative 5 and flip the sign. W is greater than negative 1. I would have an open circle at negative 1 and shade to the right. Again, I have like terms. A like terms means that you have the same variable. So, and you have the same exponents. In this case, there is no exponent, which makes it the invisible, one exponent. 7y and a positive 6y, 13y, minus 35. Add 35 to both sides. 65 is less than or equal to 13y. These canceled each other out. Divide by a positive 13, so I do not flip the sign. 5 is less than or equal to y. But now, when I want to move the y to the opposite side, I need to flip the sign. Y is greater than or equal to 5. Doesn't change it. Y was always greater than or equal to 5. It's just that I need to say the variable first, so I need to flip the sign. What if I have distributive property and I need to clean that up? Well, yeah, absolutely have to. 8 times 3x is 24x. 8 times a positive 1 is a positive 8. Remember, the sign goes with the term. This is 8 times a positive 3, 8 times a positive 1. Now I subtract 8 from both sides. I'm left with 24x is less than 120. Divide by 24, which is positive, so I do not flip the sign. X is less than 5. I used distributive property. I then isolated x. I have my inequality solved. X is less than 5. Open circle at 5, shade to the left. All right, let's use distributive property. 8 times 3x, 24x. 8 times a negative 5. The sign goes with the term, negative 40 plus 20. So I did distributive property. Now I have like terms. I have two constants. I have a negative 40 and a positive 20. Combine them together and I have a negative 20. I need to isolate x. I start by getting rid of the negative 20, which means add 20 to both sides. I'm left with 24x is greater than or equal to negative 68 plus a plus and a positive 20 is a negative 48. I am dividing by a positive 24. I do not flip the sign. X is greater than or equal to negative 2. Solid circle at negative 2, shade to the right. What if I had fractions? Nobody likes fractions. Sadly, fractions are not usually our friend. And the minute you see a fraction, your first answer to me is, I can't do it. I don't understand. Okay, we cannot use that. We have to come up with a plan. How do you eliminate denominators? Because that's the first thing you want to do is eliminate the denominator. You multiply all terms by the least common multiple of the denominators. In this case, my denominators were 15 and 5. The least common multiple is 15. Multiply both sides or every term by 15. I make a distributive property. I multiply by 15 over 1, and what I get is 15x over 15, and 15 over 5 is less than or equal to 30 over 5. Now I can reduce all fractions. 15 over 15 reduces to 1x. 15 over 5 reduces to 3. 30 over 5 reduces to 6, and I no longer have a denominator. I now have 1x plus 3 is less than 6. Subtract 3 from both sides, and x is less than 3. The hardest part here wasn't the inequality. The hardest part was remembering that you multiply both sides, or actually every term. You multiply all terms by the least common multiple of the denominators. And that's how you eliminate fractions from all your problems. We did this with equalities. I'm just duplicating it now with inequalities. These were 3 very short lessons on inequalities. It was just enough to make sure that you understand greater than and less than signs in an inequality. Good luck, and please do some of the practice problems that I have included.